Okay, unbounded behavior. In other words, you're going to infinity, something's getting out of hand, you can't really measure it, so that's unbounded, okay? So, as x approaches zero, something is happening here. This is getting really small on the bottom. We're not allowed to be zero, but again, the limit doesn't care what happens at the actual place where x is zero. It doesn't care, just once it gets really close. And the closer that x gets to zero, the more 1 looks huge. You see it happening here from both sides. As x gets close to zero, the function takes off. 1 used to look small, but now as you get so tiny, as you get closer and closer to zero, they both take off in a bigger and bigger hurry to get to just the sky, infinity. Okay? So that's what they're calling unbounded. Okay? They're really talking about infinity here. Okay? And they're going to say that the limit does not exist. And that's true, it doesn't exist. Notice here, when I have, well, I'm trying to see what they're doing here. Well, you can figure that out. Basically, I like their picture and I like the limit. I'm not sure what their reasoning is down here right off the cuff. But the point is, it's getting bigger and bigger. So they would say it does not exist, but I might be tempted to say it's equal to infinity. But that's not really a number, so I'd also keep in mind that it doesn't exist, but I'd really prefer infinity. That's where we're going. So, let's see, in the figure, I suppose we should try to figure out what they're saying. This means that choosing x close enough to zero, you can force x to be as large as you want. Okay, fine. It's getting bigger and bigger. That's what the graph says. This seems unnecessary. Using a graph to find the limit. Alright, so we look here and we say, as x approaches 1, okay, here's 1 right here. What's happening to the function? Well, as x approaches 1 from the left, it starts taking a nosedive. Why? Well, let's see. We're saying we're subtracting 1 and we're less than 1. We're not allowed to be 1. So the closer we get to 1, okay, so we're saying like 0.9, and then we're saying 0.99, you know, and 0.999, and so this is getting smaller and smaller on the bottom, but it's still negative because the negative 1 is still always bigger than the things that come from the left. So it's getting, you know, it's going down to, this is getting really, 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 really close to zero. So the 1 looks huge, however, the bottom has a negative sign. So it's going without bound to negative infinity, okay? Here's the thing, on the other side, it's not acting like that. On the other side, as x approaches 1 from over here, it takes off. Why? Well, now on the bottom I say 1 over, let's say 1.1. And I say, well, I'd like to get a little closer. Okay, how about, a little bit closer. Okay, but here's the thing. It's still beating the negative 1. I'm not by much, you know, but it's still more than negative 1. So as 1 gets to look bigger and bigger, because as 1 looks bigger and bigger because the bottom looks smaller and smaller, it's taken off. 1 looks bigger and bigger, but it's not negative anymore. Now, what does this mean? On one side, it's going to negative infinity. On the other side, it's going to positive infinity. One of the basic ideas of a limit is that as you approach whatever it says, as you approach 1, it needs to be the same from both sides. So I would like to say that it equals, you know, infinity or something, but it doesn't. It equals negative infinity on one side and positive infinity on the other. So the only thing I can say is it does not exist. I'd really rather say something else, but since they don't agree from left and right, I have to say it doesn't exist in any kind of way because they can't agree.